So, hello everyone. The other day I was looking at my mixer's spec sheet, and I'm not an expert, right? But I'm curious, so I was looking at the spec sheet, and I noticed that it say that the monitor outs on my mixer were balanced outputs. So I was like, what do you mean balanced? I know what a balanced cable looks like. This is usually what we think of when we, or at least when I think of a balanced connector. And in my mixer, those connectors are just phono jacks, right? I'm gonna show you. This is my mixer. It's a Yamaha, and these are the monitor jacks. So as you can see, those are just phono jacks. So I was like, why does it say those outputs are balanced outputs and carry balanced signals? So I researched the matter a little bit, and I'm gonna show you what I found. And at the end of this video, I'm gonna make a balanced cable because I wanna use my mixer to the best of its potential. First of all, what's a balanced signal? Well, you have normally you have your regular audio signal, right? You probably have an instrument or a microphone, or not a microphone. Forget I say that. You have an instrument or a CD player or an MP3 player or your stereo or whatever, and that thing has outs, right? So it has left and right, and each one of these is carried through, in many cases, one of these. This is a phono mono connector, and this phono mono connector, you have one here, you have one here, and the phono connector basically carries, this is ground, and this is your hot. This carries the signal for the left channel, and the other one carries the signal for the right channel. So this is a mono signal that is carried through this type of connector, and it's very simple. It's just the voltage that you can measure at the tip with respect to the voltage that you can measure at the sleeve, this part here. It's obviously not a sinusoidal wave, but let's just simplify it and say it's just a sine, right? So this is your regular unbalanced type of signal, and this type of connector is called a TRS connector. I'm sorry, this is called a TS connector. Why TS? Tip and sleeve. It's very simple. Tip and sleeve, right? So now what's balanced? What's a balanced signal? Well, when I historically thought of balanced signals, I thought of this type of connector. This connector is what we called XLR. Why, I don't know at this moment, but it's called an XLR connector, and this is what we typically find in microphones. The microphone signal is so minute, it's so minuscule, so small, that you need to use one of these or you will have a ton of noise. There are some cheap microphones that use just a regular phono connector, and that is not very good. A good microphone, or at least a decent one, uses an XLR connector because these guys carry balanced signals. So now what's a balanced signal? Well, you have your equipment. If this equipment is capable of outputting balanced signals, then let's separate here, then each one of these, left and right, will be balanced and needs to use one of these connectors. And it turns out that they can also use, that's what I learned, one of these, but we'll come to that later. So the thing is, in a balanced type of signal, for each one of these, it's for left and also for the right side, for each one of those, you carry two signals through the same cable. One is your regular sine wave, right? Again, it's most likely not a sine wave. It's some sort of very complex audio shape. But to simplify, let's now look at that. But this is a sine wave, and the other side carries the inverted version of the same thing, like this. So what happens is, now obviously this connector has then three wires. One of those is ground. The other two are these two signals. Okay. So what happens is, when you have a length of wire, right? This connector leads to some length of wire, and that cable, and that cable inevitably picks up noise from the ambient, from radio waves, from your microwave, from the electrical connection in your house. So that cable picks up noise. So you end up having like this distortion. So it's not harmonic distortion. It's just you have additions to these waves that shouldn't be there, and it affects the same. It affects both wires the same. So you get like a little extra shape here that shouldn't be there. This is noise. This is noise. You get the same here, and you get a little extra here. You get same here. A little extra here. You get the same here, right? Both wires that are connected to two of those terminals in the connector, both are affected in the same way. So now the genius of this is, when these signals reach the preamplifier or the power amplifier, when it's a balanced signal, that amplifier or preamplifier is designed to invert one of them. This is called hot, this is called cold. All right. So the preamp, let's say cable, this is what you see in the cable, and this is what you are going to see at the preamp. I'm sorry, I'm not preamp or amp. I'm not making the best use of this sheet of paper, but anyway, when the signal reaches the preamplifier or the amplifier, this device inverts the cold signal. You get your hot signal with the noise, and then the destination device, the preamplifier or the amplifier, inverts the other one. So you have again your original wave, right? Wave shape, and the noise too. But the noise is also inverted. The noise is also inverted. Yeah, like this. We have this shape here. I'm inverting it completely, and this is what you have here. So this goes to the other side. You have this. This goes to the other side of the zero, and you have this. And what happens? The preamp or amp zooms up both of these waves, and what happens then is you have your original sound wave, right, with twice the amplitude, which is good. You are just want to have more volume, and these guys end up canceling each other because now they are inverted. So you have your original waveform from the source minus the noise that it picked while traveling through the cable. So now again you have well, for that you have, well, again this is your regular TS connector, you have your hot, which is the tip, and you have your ground, which is the sleeve, hence the name TS. And then you have your balanced connector. This is I'm not sure if this is the male or female, but you have both connectors here, and this is called an XLR, and this is a balanced connector, right? And then what I just discovered was you can carry balanced signals using a regular stereo phono jack. I mean, this type of connectors are normally, well, most people associate this type of connectors with stereo signals. So you can connect this to a stereo amplifier, and it will carry. This again is ground. This will be the right channel, and this will be the left channel. And this type of connector is called TRS, for tip, ring, and sleeve, right? It's obviously not in order. Tip, ring, sleeve. Okay, and this is how it looks when you use it to carry a stereo signal. So you can carry a stereo signal unbalanced with this type of connector. You in one single cable you can transport the left and right channel, but you can also use it to carry balanced signals. Just like the XLR connector, you can use a stereo TRS connector to carry balanced signals. How it will work? This will be ground, this will be hot, and it will be cold. And obviously it will be a mono signal because you are using the same information here and here, just inverted, right? Hot is your original wave shape, cold is your inverted, hot, cold, and ground. So it will be a mono signal, but it will be balanced, and it will eliminate the noise. And obviously you need to use two of these if you want a stereo sound environment. Now again, these microphones need to have balanced signals because their output is very small. A guitar is a little bit hotter. It can withstand noise a little bit better because the source is of a slightly higher voltage, still not as high as what we call line level, but guitars can get away with using this type of connector, and in reality they have, I mean, it's not very often seen that guitars use like this connector or this connector for balanced signals, but microphones need to use this. And in the case of my mixer, and I also went and looked to my monitor speakers, they can accept a balanced signal using a TRS cable and connectors. So what I'm going to do today is I'm going to build TRS cable, a balanced cable with TRS connectors to carry that signal. I'll tell you, I try to use the opportunities I have to source good quality connectors. You can find those connectors here where I live in Mexico, but they are very expensive. So I try to use the opportunities that I have to be in the U.S. To source, to stock some good quality connectors. Now that said, you can get some quality stuff here as well. Not very expensive. But it's not very expensive. This brand. You can do much worse than this. This is a good quality connector. It's good. It's not expensive. It's very affordable, and it's very solid. It's all metal. It's good. I mean, you can I mean, you can use this type of connector without any concern. Cable. This is the cable that I like to use. It's difficult to find on the street, but you can find it online. It's called Pro Sound. That's the brand name. I'd say it's made in Italy. I don't know if that's true, but this thing is good. It's quality rubber, and I have measured the capacitance of this cable against many other cables in the market, and this is king. This really causes the less degradation to your treble signal. I'll try to make a video about that later. That's very interesting. So what you're gonna do is you take a sharp knife, right, and you cut about half an inch of insulation. I don't go all the way down, because you can easily damage the shielding. I'll show you. As you can see, I didn't go all the way through. So what I do is just bend the insulation like that, and it will rip right away. Right. Cut a little bit more. Cause a little rip on it, and it will propagate right away like that. So this a balanced cable or a stereo cable. This is a balanced or a stereo cable. Usually has, well, all the time it has the shielding, and the shielding is this bare copper element that actually surrounds all the cable. And this element, this bare copper element carries the ground signal. Why it is done this way? Because the noise will first hit ground and it will be eliminated. Again, if that will be true 100% of the time, or if that was 100% efficient, you will need balanced signals. But it helps a lot having your shielding in all the surrounding all the exterior of the wire. And then you have for a stereo or balanced cable, you have two wires. It will be not necessarily you can reverse them, and as long as you reverse the order in the other end, that will be okay. But usually it's easy to remember that red is hot and white is cold. And a good quality cable has this filler. This is a cotton filler that goes all the length of the wire, and what this does is it dampens the noise that the cable is prone to generating when you drag it through the floor. I mean, it can pick up noise in that way, and this cotton filler dampens that effect. So a good quality cable has this. It's a pain to remove this cotton filler when you want to solder the wire. What I can tell you is just do your best to remove the cotton filler. Don't wait until you have all the strands together. Just go ahead and cut as many as you can when you have the opportunity. Don't worry too much if you also cut a few. If you also need some of the actual copper strands. I mean, you can lose a few of this in a cable that is not meant to carry high currents. So just do your best to separate the cotton filler from the copper shielding. But it's very important also that you eliminate all the cotton filler from your cable end before proceeding with the actual solder, because if you leave any cotton in your solder, that will ruin it. So luckily this cable has two ends, and I already prepared the other one, the other end, and that one is right here, right? So it's I have twisted the copper wires. I have the cold one also with the insulation removed. Now we're going to remove the insulation on the red one, about the same height. I do it like this. I never got caught doing this, so but anyway, be careful. I'm not advocating doing this like I'm doing myself right now. Okay, I can tell you is the cable in this case protects my finger from being caught, but well, that's the way that I do it. You remove the insulation and you twist the cable. Now it's time to install, pre-assemble the connector. This is my connector. It's a TRS, and it's very important. Very important. I cannot stress it enough. Pay attention to the order of assembly. I have had to solder more than one connector once the job is done because I forgot to pre-assemble something. So put the wire in the cable in the same order. So first one is this. It would have been easier if I did this first before preparing the ends, but anyway, so the that part goes first. Then you have this, which is like a clamp for the cable. So you slide this next, and then what's next? You think it's this part? No, it's not. It's your actual connector, and then this part, the sleeve, goes after on top of it. So it's very easy to miss. Again, each connector is different. Every connector is different. In this case, the hardened by Captain connector, which again it's a good quality connector, is assembled that way. So twist the ends a little bit, right? Let's measure. Okay, and I'm guessing I'm going to nip this at about this height here, about here. Yeah, it should be okay. And once just a little bit shorter. You want these wires to reach the soldering points like straight ahead, right? I mean, the connectors have these holes in there that you can use sometimes to help you secure the wire while you apply the solder. But many times also, yeah, run out of batteries. Anyways, next thing you do is, I was saying, you want the wires to attack the connector like straight ahead, like in a straight way. Sometimes you can use these orifices here, these holes, to kind of secure the wire while you solder it. But the result many times is a wire that sticks out at 90 degrees. Then that makes it difficult to assemble the connector later. So next thing you do here is you need to tin the wires, or the cables in this case. We use some soldering paste and tin. Here, here, here. Then you do the same, the connector. Right? Then it's a matter of bringing both together with some more heat. You can see I'm not applying any extra solder once I have tinned the wires properly, and that's a great advantage of thin the wires, because otherwise you need like 3 hands to solder, right? And the last one is it's done. Okay. It's not super pretty. I think it will be okay. Now we bring the clamp on, and the lower half, the connector, and then this part here. I think we're good to go. Last thing you want to do to make sure everything is fine is test your cable. Okay, so the probes will tell me when there is continuity, so you want continuity between the 3 different sections. No continuity, none. We have continuity here, obviously, because it's the same. You have continuity with the other corresponding section, which is the sleeve. Yes. You do the same with the others. I'm now in the ring. Nothing here, nothing here, nothing here. We have continuity here. And last is the tip. Nothing here, nothing here, continuity here. So cable is good. That's how you do it. Thanks for watching.